And again, hopefully you caught my edit at the end of the last video and were able to see the improved version of the two at a time parallel resistor adding in case you'd like to do just two at a time. This way you don't deal with one overs, but it's up to you. You can add more than two at a time with the standard version of the equation. But okay, feel free to look through this on your own. I do have a slide here of all your parallel circuit equations at once. These are the equations we'll follow when we're doing parallel circuit problems to help you with those charts. Same kind of charts that we use in the series circuits. Here's a side-by-side of the series and parallel circuits. You see that in series, your currents are all equal. Voltages add up to a total, as well as the resistors. They add up to a total. For parallel, though, it's the voltages that are all equal, while our currents add up to a total, and our resistors add up in this 1 over fashion. And then, again, your tables have 1 over the equivalent resistance, equaling all those 1 overs added together. I like to think of it as you add up all the 1 overs with a big parentheses of this answer raised to the -1, mathematically identical. And as always, don't forget your Ohm's law. V equals IR for any single component works for both sets of equations. All right, so let's actually try a problem here with parallel circuits. Let's say we've got just a 2 resistor parallel circuit connected with a 24-volt battery. These two resistors are 30 ohms and 60 ohms. All right, so I have everything solved here at the same time. We are solving in order of red, orange, green, blue. So going back to the givens, we know the voltage to the battery is 24 volts. We know the resistor values. So I filled those in black. Resistor 130, resistor 260, total voltage from the battery, 24 volts. All right, well, in a parallel circuit, you guys did all those exercises with adding resistance, so hopefully you are an expert in them by now. 30 and 60, we know for sure the total is going to be less than 30, comes out to be 20. Here's our extended version of the standard equation, 1 over 30 plus 1 over 60, and that makes 20 when you have the inversion with those two. If you would like to try the 2 at a time equation, then this 30-60 combo turns into 30 times 60 divided by 30 plus 60. You're going to get 20 if you try that again. That would be 1800 divided by 90. That is 20. But if you don't like that equation, you want to stick with the standard 1 over versions, it's all good. So that's how we get our total resistance. Looking at the Kirchhoff voltage loop rule, where all the voltages in parallel are all equal, well, that makes it easy for the voltage. We know the battery's 24. Every resistor will also have 24 volts, so we'll fill in 24s over here. The currents are unknown up to this point. So far, we've got the R's and the V's all covered. Well, but that's fine because we can always use V equals IR to fill in any row. So as long as we have 2 out of 3 in the row, V equals IR fills in the third. In this case, if we're solving for all these I values, the current values, we'll take voltage and divide out resistance to get current. So just looking at the total first, we have 24 and 20. We'll take the voltage, divide out the resistance, 24 over 20. That gets us 1.2 amps. That is our total current. That's the current coming out of the battery here. That current will come along and split. So the currents going through number 1 and the current going through number 2 are not going to be 1.2. Each of them is less than 1.2. And together they will add up to 1.2. What exactly are they? Well, we'll just do the same exact thing we did over here. I equals V divided by R, Ohm's law. For our resistor 1, 24 over 30 will get us 0.8 amps. Resistor 2 is 24 over 60. That gets us 0.4 amps. And just to check, 0.8 plus 0.4 equals 1.2. The current equation is valid even though we didn't use it. This is just one example of a parallel circuit problem. You can take a look at this on your own time to help you with the chart versions I've given you. But please just keep in mind, it's not the same as series. In series, this all added up, and these were all equal. Totally different for parallel. In parallel, the V column should all be the same. Your R column should look kind of weird because these numbers will both be bigger than what they total to. And in the I column, they will add up to the total. Go back and double check. Even go back and check your parallel circuit simulation lab you did last week and see if you may have made some mistakes. And you probably already have my comments about them, but go ahead and try them again if you want even more practice. As always, let me know if you have questions on the question sheet or just send me an email. Hopefully this step-by-step color-coded works for you. But let me know if it doesn't, and I'll see if I can do something else. Good luck with your questions, and I'll see you next time.